Hello, students. I got an email from someone who's trying to work a little bit ahead, getting into chapter 6. So I thought I'd make a video to address the concerns. Let's take a look. So we've got 6.1 homework, question 8, 10, and 18. Okay, so let's take a look. Question 8, Venn diagram. Okay, so let's go forward and see the rest of the question. Use the picture from A representing people in algebra, B representing people in a biology class to express the fraction of elements in the indicated sets as part of the universal set. All right, so we are looking at, first of all, a universal set. So before we do anything, we might want to jot down a few quick numbers here for ourselves. Oh, and just so I remember, 8, 10, and 18. Okay, so just so I remember, so when we're looking at this, we have the universal set listed out here. So the number of things in the universal set is 17 plus 4 plus 13 plus 9. Okay, well, let's hear 17 plus 13 with compatible numbers gives me 30 plus 4 is 34 plus 9. Well, that must be like 10 minus 1. So 34, that'd be 44. So minus 1 would be 43. 43 in there. The number of things in A is the 17 and the 4, which is 21. The number of things in B is 17. And I think that probably gets most of it, but let's jump through the rest of the questions here. Okay, so it says the fraction of elements in here. So what we really want then is we want the number of things in A union B divided by the number of things in the universe. Universe has 43. How much is in the union? Well, you can look at the picture to discover the union. Remember, union is A or B. So that would be any of those three numbers. So 13 and 4 is 17, plus another 17 is 34. So I could write that as a fraction for part A. Let's see here, part C. I mean, again, all of these are going to be pretty, oh, there's B, B's over here. So A, take away or set difference, B complement. Okay, so well, here's all of A and take out everything that's not in B. So take this part out. The only thing you're left with is 4. So this would then be 4 elements out of the 43. And then here, yeah, once you know how many are in the union, you know how many are not in the union. And that would help you do this bottom one over here, which is the union complement. And don't forget how many things are in the empty set. So the empty set would be a fraction. So a fractional piece out of the 43 that are there. All right, so let's see. 8, and we said 10. Find the simplest form. Okay, so now we're looking down here at question 10. Find the simplest form. Well, yeah, I mean, you got options here, but the simplest form, remember, the simplest form would be when the GCD is 1. So the GCD between 0 and 68, this was a question out of chapter 4, 4.3. What is the GCD of 0, comma, A? And that was even in the math connections portion. And what we saw is that it would have to be the largest number, the greatest number that divides both of these. Since every number except for 0 divides 0, the biggest number we could choose is 68. So then you simply floff with 68, meaning divide out that factor of 68, and 0 over 68 would look like 0 times 68 over 1 times 68. And that's where you could say, okay, there's my common factor. And that would leave you with 0 over 1. Or if you chose to write it that way, you could just simply write it as 0. But if you wanted a fraction, simplest form, it would be 0 over 1 because we need that GCD to equal 1 itself. Same is true for B. This is 84 squared. So just if the 84 squared is giving you trouble, go back and factor. What does 84 equal? Well, there's a 2 in there. So it's 2 times 42. 42 has a 2 in there. So 2 times 21 times another 2, because now I have two 2's. And 21 is 3 times 7. So There we go. So this is 2 times 2 times 3 times 7. 4 times 3. So if you want 12 times 7. So this becomes 12 squared times 7 squared. And 91. Well, I got to do 91. Well, 91 is 7 times 13. You could do that with the square root property if you wanted to. The square root of this turns out to be, let's see here, a little bit over 9. 9 times 9 is 81, so a little bit over 9, which means I have to check 2, 3, 5, and 7. Again, that's from chapter 4, 4.2. So I have to check 2, 3, 5, and 7 to see if this number is prime. I check 2, it's not. Check 5, it's not. Check 3, 9 plus 1 is 10, it's not. Check 7, and guess what? 91 breaks down into 70 plus 21, which means it's divisible by 7. So again, you end up with 7 squared times 13 squared, and then look for those, because we're thinking about this as a fraction, 84 squared over 91 squared, you should be able to see some common factors and then think about what remains. And for the last one, 703 and 662, again, you do have options here. I mean, there's nothing wrong with going through and doing a little checking to see if we have common primes, right? So you're looking for that GCD. Maybe, here's a big maybe it's time to jump back into what we know, which is Euclidean algorithm. So I've got 703 and 662, and I could say it equals one of those. Let me grab my calculator here, and let's see. So 703 minus 662 gives me 41. And let's see here, 662 equals 41 times how many? Let's see here, 662 divided by 41. 662 divided by 41, and it gives me 16.14, so that's 16 times. So minus 41 times 16 leaves me a remainder of 6. Okay. Well, whatever my magical divisor is, it has to divide 662, 41, and 6. So if you just pause for a second, you've reduced this problem down to finding the GCD of 41 and 6. 6 has factors of 2 and 3, and neither one of them work here. So you could kind of stop there and say the GCD is 1. So the GCD of 662 and 703 is 1, which means if you tried to write them as a fraction, you wouldn't be able to simplify any more than there already is right here. So that's how all the skills that we've learned to this point can help make things a little bit easier now that you are dealing with fractions. So let's jump back to the page over here. And what would we say? 10 and, oh, and 18, I think. So let's scroll down and take a look at 18. Let me make sure. 10 and 18. Got it. Okay. All right. So solve for x in each of the following. Let me give a little bit of white space here. Ooh, everything disappears. There we go. Okay. And so as you're working through this one, some techniques that you already know about, again, algebra is a prerequisite for this class for a reason. But as you go through and say, well, wait a minute, let's see, if I had 2/3 equals x over 18. I mean, you've probably got, I don't know, maybe a dozen different ways to solve this, depending on what you're looking at. One way is to kind of ignore algebra and just get that denominator to be the same, and then see what happens. So here, a denominator that would match between 3 and 18. If you wanted to do this, it would be the least common multiple of 3 and 18, and that would be 18, because 3 goes into 18 perfectly. So then come to the side and do 18 divided by 3, and that will give you 6, and that is your magical floffing number. 6 times 2 is 12. 6 times 3 is 18. And what you get is something really beautiful, because the 18s match up. And if those match up, what's on top has to be equal. So there's a really nice way to do that. But you could, depending on the classes that you may have taken previously, you may have additional algebra skill, in which case you could choose one of a number of options. Option 1 is to multiply both sides by the denominator here, which again is getting x by itself. Okay, so if you do that, then over now we just have x by itself. But back here, you could say, how many times does 3 go into 18? 3 goes into 18 6 times, and 6 times 2 is 12. So once again, same answer, but a slightly different method to doing this. And the third technique is one that we will learn and brush up on a little bit later in proportional reasoning. However, if you have this one, feel free to use it. And it's the idea that if they are equal, then if I was to floff up the entire thing, forgetting about least common multiples and just finding the common multiple of 18 and 3, the end result would be this one would get an 18, this one would get a 3, this would get a 3, this would get an 18. And really, you end up doing something that a few people might remember. Maybe a teacher called it cross multiplying. I would never want to use that terminology because people are going to screw that up every chance they get. But the end result turns out to be the same. Take your 36 here, and it equals 3 times x, and then simply divide both sides by 3. And guess what? You have x is equal to 12. Not surprising. Doesn't matter which way you do it. Those are just a couple of the techniques you could use. Let's jump in and try the other one, because the other one looks a little bit weird. Maybe you're in that boat. You're like, what is happening there? There's a lot of variables. But again, don't let it freak you out. So what? So there's variables. You could use all the same techniques that we had in the past. 3x over x squared. When are these equal to each other? Well, let's see here. So I could do the floffing, which means I need a common denominator. This one on the right has an x squared. This one on the left would need an x in both cases. And so then as I simplify, I now have 3x over x squared. That's this one on the left. And it is going to equal 3x over x squared. And you might notice something. These look exactly the same, which means no matter what values you put in for x, the left side is going to equal the right side, with one small exception. And again, this is something that we have to realize whenever we're dealing with fractions is the denominator cannot be 0. And anytime you have a variable in here, like here we have x on the bottom, we just have to say, look, when x does not equal 0, these are always equal. Okay. So you could also say all integers except 0. That would work. So again, you have a lot of different ways you could phrase it, but the key thing is if you're trying to plug in integers that are going to work for x, you get any of them. As a matter of fact, if you were to go a little bit further, we could talk about not just integers, but real numbers, and any real number would work here. And it just says solve for x. It doesn't say find the integer values. It just says solve for x. So any integer would work here because when we're dealing with fractions, we're talking about a ratio of an integer to an integer. And there we go. So that wraps it up for the few questions so far out of chapter 6.1. All right. I'll see you shortly. Off you go.